Welcome. Let's talk about the easiest lesson that you're going to have in Module 2, or Module 3, whichever one this is. So we are in Module 3. Let's see, where's my mouse? It's over there. Come on. Boop. This is the fundamental theorem of similarity. Okay? You're going to hear this a bunch. The fundamental theorem of similarity. So taking a look at this very first example, there is very little that you do not know how to do already. So in the diagram below, points R and S have been dilated. Image or pre-image, image. How do I know? No primes, R prime, S prime. They've been dilated from 0, from point O, which means they're going out from point O, and it's an enlargement by a scale factor of 3. If OR is 2 3/10, what is OR prime? Well, to do this, we're going to say, okay, we don't know what OR prime is. We know what our scale factor is, and we multiply it by 2 3/10. That gives me 6 9/10. Relatively easy. If O prime or OS is 3.5 centimeters, would help if I labeled. What is O prime S prime? Well, once again, we take our pre-image, we multiply it by the scale factor, and that gives me my image. So I'm going to take my calculator because I don't feel like thinking. 3 5/10 times 3 gives me 10 5/10 centimeters. So this is 10 5/10 centimeters. Okay, that's all well and good, Mr. H. That's not the fundamental theorem of similarity. Why not? Well, let's keep going down because there's questions here. Connect the point R to point S and the point R prime to point S prime. What do you know about the lines that contain those segments? And then what is the relationship? Identify the pairs of angles. How do you know they're equal? And that's pretty much our lesson. So let's see what happens. Okay, so I'm not going to move off of this too much more. So first off, the key to the fundamental theorem is knowing that if I connect 2 points and then the same, so I connected my image points, now I'm connecting I connected my pre-image points, now I'm connecting my image points. Simply by looking at these lines, you should know something about them. What do they appear to be? Parallel! Whoa, you guys shouted through the computer. Look at you, you're so smart. They're parallel, okay? How can I prove that they're parallel? Well, I'm going to get this guy here, and I'm going to come here and I'm going to measure my angle, plain and simple. So this is just shy of 70 degrees. Oh, let's see, hold on. Nope, it's exactly 70 degrees. That one's exactly 70 degrees. So if these are both 70 degrees and they're cut by a transversal, that means these lines have to be parallel. Those are what's called corresponding angles. Let's see if I set it up over here. Well, this is 30 degrees. This is 30 degrees. Oh man, let's see, is this going to be 30 degrees too? I bet. Hot darn. This is 30 degrees. Therefore, again, this transversal is cutting these, and these are corresponding angles in the same place on a different line. Top left, top left. We learned about this in the end of Module 2. I want to say it was Lesson 12. So, corresponding angles. This proves that this is parallel. But the fundamental theorem of similarity says not only will RS to R prime S prime have to be parallel, but they'll have to follow the same scale factor. So immediately, I should say that RS times 3 should equal R prime S prime. How can I prove that? Well, I take my yardstick here, and I say, okay, RS, for me, because I'm up on the board, is 8 inches. So immediately, I should say 8 times 3 is 24 inches. Let's see if we're right. Oh my goodness. Oh my goodness. There it is. This is 24 inches. The fundamental theorem of similarity tells me two things. First, that when we connect the lines, they must be parallel. No options, which means these angles are congruent because of corresponding angles. These angles are congruent because of corresponding angles. Last but not least, they have to follow the same scale factor that the sides of the angle follow. That is crucial. So again, two things. Parallel lines must follow the scale factor. Plain and simple. That's the fundamental theorem of similarity. And if you're like, Mr. H, I don't believe you, well, you can try to read this guy and understand it. But what I just told you is the fundamental theorem. Once again, you're welcome. Where's my mouse? I can't shut off the video without, there it is. Okay, bye.